day everyone, I am Kimberly Indorte, and in this video I will be sharing to you the lesson 2, which is organizing data in frequency distribution table. And for the objectives of the sharing are: first, we have defined frequency and frequency distribution table. Second, we have enumerate the steps in constructing frequency distribution table. And lastly, we have appreciate the importance of organizing data in real-life situation. So what is frequency? So when we say frequency, it is the number of times the data appears or repeat in the sequence. And when we say frequency distribution table, so it is a systematic way of presenting data using a table. So the data are grouped into different intervals or number of classes assigned by the researcher. So usually the ideal number of classes is from 5 to 20 only. So we have important terms that we need to know, especially in constructing frequency distribution table. So first is we have range. So when we say range, it is the difference between the greatest value and the least value in set of numerical data. Second, we have class interval. So when we say class interval, it is the number of classes. And next, we have class size. So when we say class size, it is obtained by dividing the range by the class interval. Fourth is lower limit. So it is the smallest value in the class. And the upper limit, we have the greatest value in the class. So you have to familiarize these terms because we will be using that one as we go along to our discussion. Moving on to steps in constructing a frequency distribution table. So we will be using this example. So here are the savings scheme has in the month of May. So first step, we have choose the number of classes of the distribution. So usually the ideal number of classes is from 5 to 20 only, as what I have said earlier. So in our example, so for Kim savings, so let us use 10 as the number of classes or the interval. So in this example, so I will be the one to give you the class interval so that we will have the same answer later on. So therefore, our class interval is 10. For our second step, we have get the range. Again, when we say range, it is the difference between the highest value and the lowest value. So we have this formula. Range is equal to the highest value minus the lowest value. So here in our example, so our highest value is equal to 60 and our lowest value is equal to 10. So in applying the formula and getting the range, we have highest value minus the lowest value. So again, our highest value is equal to 60 minus our lowest value is equal to 10. So 60 minus 10 is equal to 50. Therefore, the value of our range is equal to 50. So remember this one because we will be using this in our next step. Alright, for our third step, we have solve the class width or the class size by using the formula. So we have this formula in solving for class size. So class size is equal to the range divided by the class interval. Since we have already solved for the range, so we simply substitute the value of our range, which is 50, right? Divided by our class interval, which is 10, as what I have said earlier, that we will be using 10 as our class interval. So 50 divided by 10 is equal to 5. So therefore, our class size is equal to 5. By the way, you have to take note this one. If the class size has a decimal, always change it to whole number by rounding off the value. So you have to remember the rules in rounding off a number. For example, 0.4 and below, so our whole number is still the same. For example, 4.4 is equal to 4. and 0.5 and above, we will add 1 to our whole number. For example, 4.5, so 4.5 will become 5 because we will add 1 to our whole number, which is 4. So 4 plus 1 is equal to 5. I know you know this one because this is already tackled in your previous lesson in rounding off a number. Alright, for our fourth step, we have pick a starting value that is less than or equal to the smallest value. Then, determine the next lower limit by adding the class size. So here in our example, so as you can see, the lowest value or the smallest value we have is 10, right? So that's why we have 10 there in our first row. So again, a row in a table is what we call the interval. So again, to determine the next lower limit by adding the class size. So again, since we have already solved for the class size, which is 5, right? We simply add 5 to our first row, which is 10. So 10 plus 5, we have 15. That is why we have 15 in our second row. So 15 plus 5, we have 20. 20 plus 5, we have 25. 25 plus 5, we have 30. So on and so forth. So you have to continue adding 5 until we reach 60, which is our highest value. Again, so 10, 15, 20 to 60. So this part is what we call the lower limit. Alright, for our fifth step, we have the upper limit of the first interval is determined by subtracting 1 from the second lower value. So repeat the process to complete the intervals. So again, in our table, so our second lower limit is 15. Again, we simply subtract 1 in our second lower limit. So 15 minus 1 is equal to 14. That is why we have 14 there in our first upper limit. So in order to solve for the second upper limit, we have to add our first upper limit by our class size. Again, our class size is 5, right? So we simply add 14 plus 5. That is why we have 19 in our second upper limit. So 19 plus 5, we have 24. 24 plus 5, we have 29. 29 plus 5, we have 34, and continue adding 5 until we reach 64. So 14, 19, 24, 29, 34 until 64. So this part is what we call the upper limit. Okay, let's proceed to our next step. We have step 6. Get the tally of the data. So here in this step, we have to be very extra careful in tallying the data. So again, in our first interval, we have 10 to 14. So this includes 10, 11, 12, 13, and 14. So second interval, we have 15, 16, 17, 18, 19. So here in our interval, we will tally if this our example here belongs to that interval. For example, we have 50. So 50 belongs to 50 to 54, right? Next is 30. So 30 to 34. So 40, we have 40 to 44. 20 belongs to 20 to 24. So 50, 45, 60, 35, 45, 25, 35, 30, 15, 20, 45, 30, 35, 55, 15, 35, 25, 30, 25, 30, 40, 25, 20, 40, 45, 10, and 40. Okay, for our next step, we have step 7. Write the equivalent number of frequency from the tally and total the data. So use n to represent the entire population. So in solving for the frequency, we simply add the tally. So in our frequency, in the first interval, we have 1. In our second interval, we have 2. In our third interval, we have 3. In our fourth interval, we have 4. In our fifth interval, we have 5. So we have 4, 4, 4, 2, 1, and 1. So if we add this all, it will result to 31. That is why we have n to represent the entire population is equal to 31. Alright, in this table, to solve for the cumulative frequency, first is you have to look at the first interval in our frequency. We have 1. So that is why in our first cumulative frequency in our first interval, we have 1 there, right? And second step, to get the second interval for the cumulative frequency, which is 3, we simply add the first interval to our second interval in our frequency, which is 2. So 1 plus 2 is equal to 3. Again, to solve for the second interval or the second row for our cumulative frequency, we simply add the first row, which is 1, to our second row in our frequency, which is 2. So 1 plus 2 is equal to 3, and repeat the process. So again, 3 plus our third row in our frequency, which is 3. That is why we have in our third row in our cumulative frequency, we have 6. Again, 6 plus 4, we have 10. 10 plus 5, we have 15. 15 plus 4, we have 19. 19 plus 4, we have 23. 23 plus 4, we have 27. 27 plus 2, we have 29. 29 plus 1, we have 30. And 30 plus 1, we have 31. As you can see in the last number in our cumulative frequency, 31 is equal to the total of our frequency, which is n is equal to 31. Again, to solve for the cumulative frequency, I know some of you are very confused. Again, since our frequency here in our first interval, or again in the first row, which is 1, we simply copy 1 in our first row for our cumulative frequency. So 1. So once since we have 1 here, look at the frequency in our second row, which is 2. So you have to add that 1. So 1 plus 2 is equal to 3, right? So that's why we have 3 there in our second row in our cumulative frequency. So again, repeat the process. 3 plus 3 is equal to 6. 6 plus 4 is equal to 10. Alright, for our class boundaries, as you can see, it is divided into 2 parts, which is the lower boundary and the upper boundary. So in order to solve for class boundaries, we simply look at the class interval. So again, in our first class interval, we have 10 to 14. So again, 10 here is our lower limit and 14 is our upper limit. So again, to solve for the lower boundary, we simply subtract 0.5 to our lower limit, which is 10. So 10 minus 0.5, that is why we have in our lower boundary, we have 9.5. And to solve for our upper boundary, we simply add 0.5 to our upper limit, which is 14 plus 0.5. That is why we have 14.5 in our upper boundary. In our second, so 15 minus 0.5, we have 14.5, and 19 plus 0.5, we have 19.5. So 20 minus 0.5, we have 19.5. 24 plus 0.5, we have 24.5. 25 minus 0.5, we have 24.5. And 29 plus 0.5, we have 29.5. So continue that, adding and subtracting 0.5 until we reach 50.5, and 64.5. That is how to solve for the class boundaries. Again, to solve for the lower boundary, we simply subtract the lower limit by 0.5. And to solve for the upper boundary, we simply add 0.5 to our upper limit. Alright, in order to solve for the class mark, we simply add the lower limit plus the upper limit divided by 2. So here in our first interval, we have our lower limit 10 plus our upper limit 14. So 10 plus 14 is equals to 24. Divided by 2, we have 12. So 15 plus 19 is equals to 34. Divided by 2, we have 17. So 20 plus 24, we have 44. Divided by 2, we have 22. So on and so forth until we reach 62. That is how you solve for the class mark. Again, to solve for the class mark, we simply add the lower limit plus the upper limit and divided by 2.